The next type of functions are the functions where you have inverse trigonometric functions. So something like this. I is equal to integral of sine inverse of x dx. So we have two functions here. One times sine inverse of x. So you can take u as sine inverse of x dv as dx, or you can take u as 1 and dv as sine inverse of x. Now to do this thing, you have to find out the integral of sine inverse of x, and which is exactly the question. So you can't really proceed, no path forward here. So we have only this choice, but it is nice because we know the derivative of inverse trigonometric function. So you have du, the derivative of inverse sine function, sine inverse, is 1 divided by square root of 1 minus x squared dx, right? And v becomes x. So if you follow this thing, you get the integral as uv minus integral of v du, which in this case is x times sine inverse of x minus v times du, which is integral of x dx divided by square root of 1 minus x squared. Okay, so this part is done. How about this guy? This can be computed using the substitution rule. So let me rewrite this thing as x times sine inverse of x minus I1, where I1 is this little integral of x dx square root divided by 1 minus square root of 1 minus x squared, right? So here the choice of substitution is you put u is equal to 1 minus x squared. Now again, this is an abuse of notation. U is a different u here, right? So don't confuse this u with this u. Completely different problem, right? So if you substitute u as 1 minus x squared, you get du is minus 2 times x dx. Okay, now how about this? So we have x dx, we don't have minus 2 dx, minus 2x dx, so we multiply and divide by minus 2, and you get I1 as minus 1 over 2 times integral of minus 2 times x dx square root 1 minus x squared. Now we are happy because this du is sitting right here, and then you have this u, and we know everything about this integral. It is half times integral du divided by square root of u. So it is integral of u to the power minus half, and we know the integration of this from the table of integration. It is u to the power minus half plus 1, which is half, divided by half, plus the constant of integration. Okay, so you get this thing as half and half will get cancelled. I get minus of u to the power half, but u is, we have to resubstitute, u is 1 minus x squared, so you get this thing as minus half, minus square root of 1 minus x squared plus c1. Okay, so let's substitute back. We just showed that I1, which was integral of x dx divided by square root of 1 minus x squared, is equal to minus square root of 1 minus x squared plus c1. c1 is the constant of integration for I1, and then you have this I, the original problem, so you have to substitute this guy back here, and you get x times sine inverse of x minus I1, so it is minus of this, so it is plus square root of 1 minus x squared minus c1, right? But again, c1 was arbitrary constant of integration, so you can just change it to plus c, where c is the constant of integration. So that's how you solve the inverse trigonometric functions integral. Now again, the lesson to learn here is lesson 3 is what? If the integral is a product of algebraic function and inverse trigonometric function, okay, then what did we do? We did u as the inverse trigonometric function, right? Because we know the derivatives of inverse trigonometric function. Okay, and usually after this you have to use some kind of substitution rule to solve the problem completely. Alright, so there are things like reduction formulae. So for example, the integral to be found out is the integral of sine to the power n of x dx. How do you compute something like this? And so the question is, prove that this thing is equal to minus 1 over n times cosine of x sine n minus 1 x plus n minus 1 n over n integral sine to the power n minus 2 x dx, where this n is any integer which is greater than or equal to 2. Okay, so the way you solve this thing is you put, okay, I is equal to sine to the power n can be written as integral of sine to the power n minus 1 times sine of x dx. Okay, and then you have two trigonometric functions, right? So we don't have any rule for that, so you try to put u is sine to the power n minus 1 x and dv is equal to sine of x dx. If u is equal to this, then du becomes n minus 1 times, so it is the chain rule of derivatives, n minus 1 times sine to the power n minus 2 times the derivative of the function, original function, which is sine x. The derivative of sine is cosine of x and then dx. So that is du. V becomes the antiderivative of sine, which is minus of cosine of x. Okay, so we are ready to apply our integration by part formula. So you get I as uv, u times v, which is minus cosine of x sine to the power n minus 1 x minus integral of v times du, which is, okay, there is already a constant here, n minus 1, and then there is a minus sign, so you can combine them together and say this is minus of n minus, okay, so minus of this thing, so it will be plus n minus 1 times integral of the product, which is sine to the power n minus 2 x times cosine square. Okay, so we know this fantastic identity that sine square of x plus cosine square of x is equal to 1, which basically comes from the Pythagorean theorem. So this implies that I can substitute cosine square of x as 1 minus sine square of x in this integral. So I get the integral I as minus cosine of x sine to the power n minus 1 x plus n minus 1 times integral. Now think about it, if you multiply sine to the power n minus 2 with this, you get sine to the power n minus 2 x minus sine to the power n minus 2 plus 2, which is sine to the power n, right? So you get the first term is just sine to the power sine n minus 2x, right, dx, and the second term would be negative, so it is minus n minus 1 times integral sine to the power n x dx. Okay, but look, what is this thing? This is sine to the power n x, so this is just the integral I that we started off with. So we have, in this case, minus cosine of x sine to the power n minus 1x plus n minus 1 times sine n minus 2x dx minus n minus 1 times integral sine to the power n x dx. But if you think about this thing is just I, so I can rewrite this thing as I, you can take this minus n minus 1 I on the other side and it becomes I plus n minus 1 I equals minus cosine of x sine to the power n minus 1 x plus n minus 1, which is this term, integral sine to the power n minus 2 x dx. Okay, and what is this thing? This thing becomes just I plus ni minus I, which is n times I, right? So n times I is equal to this person. So what is the integral I? I will be equal to, you divide throughout by n and you get minus 1 over n cosine x sine to the power n minus 1 x plus n minus 1 divided by n integral sine n minus 2 x dx.